And welcome back, Physics Fans. Here we go with our second installment of the final lesson of energy. We're going to talk in Physics 11, we're going to talk about power and efficiency. Okay, so we start off right away with the definition. The rate at which work is done, or that energy is transferred, the rate at which energy is transferred, and that is equal to power. And that's the definition. Think of this in terms of how much work is done per unit of time. Power is measured in watts. That's the unit. And 1 watt is equal to 1 joule per second. Okay? Now, I don't like abbreviating the unit watts with a W because then that looks like work. Because the formula is power is equal to work over time. Or it could be power is equal to the change in energy over time, because work is the change in energy. But work and the W for watts. So whenever I write down the word watts, or I don't abbreviate it with the W, I just write down the whole term watts. I never get mistaken by just automatically thinking, oh, W, that's work. An old unit of power is also the horsepower, and 1 horsepower is roughly 745.6998. I don't know how they came up with that. That's a good research topic for you guys if you want. And in Physics 11, we'll just write down 746. So if I ever give you the horsepower of an object, that'll be the conversion factor to watts. 1 is 746. You can put that on your formula sheet. Okay, and power is work over time. I'm going to leave this bracket, a box here of formula manipulation, and we're going to start working with here. We'll do question 1, and then we'll go back to 0. How much work can a 5 horsepower motor do in 10 minutes? Okay, so a 5 horsepower motor, okay, the calculations for that is 746 watts is 1 horsepower. That's the conversion factor. Okay, so 5 times 746, that is going to be a 3,730 watt motor. Okay, 3,730 watt motor. So we're asking how much work. So our formula is power is work over time. We have the power, we have the time, so work is just going to be equal to power times time. That is going to be 3,730 watts. And 10 minutes is 600 seconds. So multiply this by 600. And whoops, I was 60. I have to multiply by another 10. Sorry, my bad. And this is going to be a power of 2,238,000. What's the unit? It will be joules. Very good. So work is going to equal 2.238 megajoules. So we get our energy around here, a lot of it, from BC Hydro. And BC Hydro sells us a product. So let's go take a look at the bill online. There's a BC Hydro bill. There's one that BC Hydro put up for John Doe. But then, of course, there's a person that has uploaded their BC Hydro bill. I have no idea why, but it's there. So there's BC Hydro bills. And way back in the day, there's a certain rate for usage and stuff like that. So we'll just use what BC Hydro put up here. BC Hydro sells 1,332 kWh. That's what they're selling, kilowatt hours. And they're selling it at 7.9 cents, about 8 cents a kilowatt hour. So they're selling you this product at about 8 cents per kilowatt hour. But what is a kilowatt hour? Well, first of all, is BC Hydro a power company or are they an energy company? Because we now know energy and power are different. It says BC Hydro is power smart. If they were an energy company, wouldn't they call themselves Energy Smart? The sister company over in Ontario is called Ontario Power. But does that make them a power company? Do they sell power or do they sell energy? Well, what they sell is rated as kilowatt hours. So let's figure out what a kilowatt hour is. That's question 0. What is a kilowatt hour? So 1 kilowatt times an hour is 1,000 watts times 3,600 seconds. So this is equal to 3,600,000 watt seconds. Well, what's a watt second? Here's the units, a watt and a second. If I bring the second up top, I get a watt second. A watt second is equal to a joule. So a kilowatt hour, 1 kilowatt hour is equal to 3,600,000 joules. So instead of having huge numbers up there, selling it at 8 cents a kilowatt hour, instead of saying 8 cents for every 3,600,000 joules, is less intimidating. So they're using a larger unit for energy, a kilowatt hour. And most people wouldn't know what a joule is, but a lot of people know what watts are, at least with light bulbs, and they know what hours are. That's how long my class is, joyfully. Okay, so at that point, you should be able to work through a lot of these questions, understanding all that, but the only thing that we haven't talked about is efficiency. So this is the last little tidbit of information you need to know. Because when we're starting to talk about energy and the uses of things, we try to make things efficient. The more efficient it is, the better we use the product, the less efficient. This is one of the reasons why Tesla is going so well, because the efficiency of their electric motors are a lot higher than the efficiency of an internal combustion engine. What is efficiency? How much you get compared to how much you put in. Okay? That's all I remember. It could be in work out over work in, or it could be power out over power in. And then you write it down as an efficiency. Okay, so let's just talk about a solar panel. A solar panel takes in 700 joules of light energy and gives off 150 joules of electrical energy. So this is the purpose of a solar panel. It takes light coming in and hitting the solar panel, and then we take it in and be able to plug it in and have an outlet and get power from it. So it's converting light energy to electrical energy. But how efficient is this one? Well, if you take a look at it, how much is wasted? If we took 700 and only got 150 out, we can easily see that 550 joules is wasted. Okay, it's not converting it to electrical energy. This could be heat coming off of it. It could be the resistance in the wires. It could be lots of different things. So what we get over top of what we put in, this is what's put in, and that's what we get. And then we change it to a percentage. So the efficiency of this is always equal to the smaller number over the larger number. And Mr. Calculator, 150 divided by 700, and then convert it to a percentage. This will be 21.4% efficient. Okay, thank you very much. Subscribe, like my video, leave a comment down below, and please follow someone else's TikTok because I don't have a TikTok.